The purpose of the boiler feedwater pump recirculation valve is to always maintain a minimum flow through the pump to protect it from overheating. Feedwater pumps are driven by large electric motors or steam turbines, with a typical power input range from 1,500 to 5,000 horsepower, but can be even larger. Due to the large power input and the fact that pumps are only about 80% efficient, the feedwater will increase in temperature between the inlet and outlet. It is typical to see a temperature rise across a feedwater pump on the order of 4 to 8 degrees Fahrenheit during normal operation. If a minimum flow is not maintained through the pump, the water will heat rapidly, causing the pump to fail. Field experience has shown this to occur in 15 to 30 seconds. The pump manufacturer will specify the minimum flow requirements in their specifications, and often it is included on the pump performance curve. As the feedwater valve opens and starts to send water to the boiler or HRSG, the BFP recirc valve will close to maintain the total minimum flow required through the pump. By modulating the two valves in tandem, power used by the feedwater pump is optimized. Once the flow to the boiler or HRSG reaches the minimum flow rating for the pump, the BFP recirc valve will be fully closed and full actuator pressure put on the valve seat. It is very important that recirc valves shut off tightly when closed for two reasons. First, leakage across the valve will damage the seats. The damage causes more flow, which causes more damage, and the leakage flow will continue to increase. If leakage is high enough, it can reduce the feedwater flow to the HRSG and significantly reduce steam turbine output and subsequently plant revenue. The valve most often used for feed pump recirculation is a Fisher HPT with Cavitrol 3 three-stage trim installed using an HTS-1 option OmniSeal and Class 5 shutoff with 800 pounds per lineal inch seat load. Cavitrol 3 trim can handle pressure drops up to 3,000 psig using 3 stages of CAV protection. There are CAV 3 designs that can handle pressure drops greater than 3,000. Please consult with the factory on options for your specific application. While Cavitrol 3 trim is an effective solution to prevent cavitation damage over time, because of clearance flow, the seat area on the plug can become damaged and will exhibit gear toothing. The valve seat will show similar damage, and leakage through the valve will be excessive. An effective solution to provide extended life, if gear toothing is an issue, is to convert the plug and seat ring in a Cavitrol 3 trim to a protected inside seat design. There is a perception that feedwater is clean. However, it is common for varying amounts of magnetite, rust, weld slag, and other debris to flow through the feedwater system, which can plug up the valve trim. An effective upgrade to solve the plugging and gear toothing issues of Cavitrol 3 is to convert to Dirty Service Trim, DST. DST has the ability to handle particulate up to 3/4 of an inch in diameter. All of the pressure reduction occurs below the seat, so there is little to no pressure drop across the seats. For boiler feedwater pump recirc applications greater than 3,000 psig, the standard recommendation is to use a Fisher CAV 4. The CAV 4 can handle pressure drops up to 6,000 psig as a standard. If your requirements are higher, please consult the factory as there may be options available. CAV 4 uses radial and axial flow to effectively dissipate high pressure drops, keeping the vena contracta pressure above the vapor pressure of the fluid, eliminating cavitation damage. Another option for new boiler feedwater pump recirculation installations is the Notch Flow DST. Notch Flow is very effective in dirty service high-pressure drop applications. While traditional Fisher anti-cavitation designs are flow-down and highly customizable, the Notch Flow DST is flow-up and non-customizable, but has a very attractive price point.